We're going to continue our debugging, testing tips, and debugging from Monday. We have those 6 examples. I'm going to go right to the code, actually. We have these 6 examples in the code. I told you all these examples are broken in one way or another, and we're going to go through and fix them. We didn't even get through 2 examples in the previous lecture. We'll try to get through 3 and 4 today, but we'll see how far we get. These take a lot longer than I anticipated. Thought we would get through all 6 in 2 lectures. Before we do that, any question? Actually, I have announcements just in case. I guess it's passed anyway. Just announcing the 2-day deadline, but that was already this morning. So 2-day deadline extension, and there was something else. Oh, the Test 9 grader has been updated. If you're having timeout issues in Autolab for Test 9, hopefully you saw the Piazza post and were able to submit before this morning to get that expected deadline. But if you're having those issues, try resubmitting. You should hopefully not have that problem anymore. At least shouldn't have the timeout issue. What I did was remove the hard tests. I had tests where I was taking the whole movies.csv and throwing a whole bunch of test cases at you. And I underestimated how slow an array list is. So if you had a slow implementation of breadth first search, it did take quite a bit longer, which is a nice conversation for CSE 250, but in 116, it's just too early to have that talk about choosing the right data structure. It's not really part of what we do here. We're just showing you how to use a variety of data structures, how they work, and then 250 is going to straighten you out on when to choose the right one. But the difference between a hash set to keep track of the nodes that have been visited and an array list is significant. It's a huge difference to the extent of a hash set would take less than a second to run all of the tests, and an array list would time out in Autolab. It would take several minutes, more than 3 minutes that we give for the timeout. Huge difference. It is important to choose the right data structures, but that's for 250 to talk about. All right. Any questions before we get into it? What about that 2-day extension? So since Autolab was down Wednesday morning for 3 hours, and I can't believe the number of complaints I'm still getting about this. Autolab was down for 3 hours, so it did inconvenience some people. So Paul and I talked about it. We decided to give a 2-day extension. So everything that was due Wednesday morning was actually due this morning. We adjusted the deadlines in Autolab and all that. So you got 2 extra days. So we gave a 48-hour extension for a 3-hour problem, in short. And I'm still having students like, we need more extension. I don't know. But yeah, y'all got a 2-day extension. That applied to the expected deadline, recovery opportunities used. Anybody who didn't finish by Wednesday but finished by Friday, I removed your recovery opportunities that were used on Wednesday morning. Updated the expected deadlines if you finished by this morning. Well, that's it, just those 2 things. And it applied to the actual deadline. So if you used your first recovery opportunity on test 8, that was also removed. And I put a pinned post on Piazza to announce it. And then I figured, so the reason we gave such a long extension, because it should, in theory, be a 3-hour extension. I gave such a long extension, Paul and I decided, just because we figured it would take a while for everyone to see the Piazza post to know that there was an extension. So if you, and it was posted Wednesday night, right? More than 3 hours before the extended deadline, at least. I forget exactly how much time. I think Wednesday night, though. So you had more than 24 hours to check Piazza and see that and everything. I think that's plenty fair. Because the outage only affected people who were working at the very last minute. I don't know. There's only so much we can really bend. And the danger of that, as with any deadline extension, we talked about this earlier in the semester for the ice storm, was it? I forget what it was. When we gave an extension. The problem with giving extensions is it gives you less time to do the next assignment. Because next Wednesday's deadlines aren't moving. We're not going to move every deadline to Friday. So it gives you less time to do A01 or to complete the tasks and prevent using more recovery opportunities. But, it is what it is. But I think that was more than fair, given the outage. All right, anyway, if you disagree, let me know. We can talk about it. But so we have this method. This is similar to the code that we saw earlier in the semester to compute letter grades. Given this grading chart for some fictitious course, of course not CSE 116, and of course not any course at UB because we don't have A pluses, or D minuses, right? I don't think we have a D minus. But some grading structure, and we want a method, compute grade, which is going to take in a numeric score and return what your letter grade should be. We're going to compute this in 2 parts like we did earlier in the semester. And of course, I changed this code a little bit so we can talk about debugging. I had to add some bugs to this. But the method letter is going to take that score and return what letter it should be. And if it's not a valid grade, it'll return invalid grade. And then plus minus, which is going to give us the modifier, either plus, minus, or nothing, that should be applied to that grade. So this is our code. I'll come back to the code so we can stare at it and try to figure out the issues with it. But first, let's do a test suite. And last lecture, I was copy and pasting test suites into other directories, and I made a cut and paste error, so I'm going to write them from scratch this time so I don't make the same mistake. So test grades at test public void test grades, no parameters. And for this, we're going to, this is a method with clear input-output behavior. It takes an int, it returns a string. It's just begging for a hash, begging for a map. It's begging for a map of integer to string. Since we know about interfaces, we're going to use the map interface instead of we're going to use the map interface instead of the now you got me distracted. So we're going to use the map interface instead of the hash map class, the concrete class. So we're going to have our test cases equals map dot of entries. We saw this last time as well. I'm going to not forget my semicolon like I did in the last lecture, embarrassingly. And then map entry, and then build my key value pairs for my test cases. So let's start right at the top. If I get 100 in a course, I'm expecting that A+. And usually, this is the point where in a lot of lectures, I've been saying, let's add a few test cases, and then we'll just call it good. This is where we would add a lot more, and I leave it at that. I want to at least one time switch that up and actually show you a full test suite, what I would build for testing this method. So what I'm going to do is grab this grade cutoff, paste it right here so I have it for quick reference, and add a butt ton of test cases. So I have these boundaries that I have for each letter grade. So writing a test suite like this, for something like this, I'm going to test each one of those boundaries. So an A+, if I get 100, I want an A+, and 97 on the low end of the range, I also want an A+. And since 100 and something like 99 could be treated very differently in our code, depending how somebody implements their code, and the way we are by splitting the 1s and the 10s and computing things separately, it'd be easy to get 99 but mess up 100 or vice versa. So I want both of those test cases, not just the endpoints for that specific situation. And then we're just going to go down this, and I'm going to make sure I hit all of the boundaries, those somewhat edge cases. I'd say these are just common cases at this point for this one. But they are on the edges of these boundaries, so I want to check every single boundary. And I'm going to do it rather tediously to show a full test suite instead of leaving it at, and then we would write more test cases like I usually do. So 96 and 93 are both A's. A minus, 90 to 92. And then I'm going to do this smarter than I did last lecture. You have the benefit of me learning quicker ways to do things. I'm going to change all these to B's, and that should be my B range. I missed a comma here. Get my C range. It should be the same cutoffs. Just in the 70 range are going to be C's. Sure, I grab that comma. We went all the way down to the D range. Fingers are too dumb to do this any faster. You just have to wait for me. And then everything less than 60 is going to be the F range. So we're checking all the boundaries, and we have this one special case of 99 to make sure that that's still an A+. And then all the F range, last time we saw code similar to this. We, if you recall way back then, we did have a bug that we refused to fix because lecture was over. We had to move on with our lives. But we had this situation where there would be F+ and F-. If you had like a 19 in this course, you would be awarded an F+, which doesn't really make sense. It's not part of the grading structure. So we want to add tests to make sure that we're getting rid of that stuff. We're going to add quite a few F tests. 59, we got to get the boundary like we did for the other ones. 59, we want to make sure that that's an F. That's the very first grade that would be an F. In an actual course, if I'm doing the grades, this would end up being a D- anyway, but anyone that close is usually going to pass in my courses. But according to the grading structure, we're going to give that 59 an F. And then we want to check the other end of the edge, the 0, make sure that that's going to give an F. And then we want a whole bunch of other test cases. We want to make sure, of course we could test all 100 valid inputs and then a handful of invalid inputs and make sure we always get the right thing. But we're not that crazy, usually, as developers. But we do want to check quite a few values in this range, especially to expose that bug that I just mentioned. Something like 39 shouldn't get an F+. Something like 11 shouldn't get an F-. And let's just get a whole bunch of values in these ranges, in these strange ranges. Get something in the mid-teens, something in the late teens. Especially because I know our code. You don't always know what the code's going to be when you're writing your test cases, but I'm aware that the code is splitting the ones and the tens digits separately. So I want to make sure I'm getting each tens digit and getting what would be a plus, minus, and a neutral in each one of them. So like 22, 28, I could have done these in order. It would have made more sense. 24, I already have 39, so how about just flat 30, 35, my 40s, 42. And I always say more tests aren't going to hurt. Having a bunch of tests isn't really going to hurt you. The only possible potential thing, too many tests, a lot of tests could hurt you, is if your tests take a long time to run. That's the only thing that's going to absolutely hurt. So if you got onto the range, like some people go crazy with things. Some people might be tempted, some of you might be tempted, well, I could just loop through every possible integer ever and make sure it's always returning the right value on every possible integer. That test is just going to take way too long to run, even though it is completely robust. It is 100% coverage on every possible input. It's usually not something we want to do because it would take forever to run. My 50 range, 54, and 59. Oh, I already have 59. Whatever, 58. So that's good for my F range, and now we want to check some invalid grades. This is one of those cases where I'm always going to cut and paste. How many times I've seen and how many of you have done something similar to this? You go like, oh yeah, this should return invalid grade. And you type this, and then you waste hours of your life trying to figure out what's going on wrong. It's because you didn't capitalize your I and G, and then you feel really, nobody ever feels good after doing something like that. I'm going to cut and paste, so I can't do anything like that. Even if this is some strange UTF-8 character that happens to look like an E, if I'm cut and pasting it, I got the right character anyway. Still got the right thing. Of course, that would be a different kind of bug we'd want to fix. So let's get some invalid grades in here to test our edge cases. I'm going to do quite a bit of them. -1 and 101. Those are our edges. We want to make sure we're hitting those boundaries hard. And then just thinking of anything else that could possibly go wrong. This is where I see so many of you shortcutting this, where you write like 2 or 3 half-assed tests, and then you submit to Autolab and say, why doesn't this get rid of the incorrect solutions? This is what I want to see is sit down and think of a really good test suite where what your goal is to really challenge your code. You are literally testing your code. You're putting your code up to the test and saying, can you get all of these test cases? And you want things that are going to trick it. You want to really throw things at your code that's going to try to challenge it and see if it can meet all of these challenges. Because if I write a whole bunch of really good test cases and my code says, yeah, I got this, I'm feeling confident that that code's actually right. So I want to really test this. So -1 and 101, decent start. I want to check something like 1,000, 1,100, 199. These are all scores that could very easily be confused for something that should be an A+, where if you're taking the tens digit, say you're taking the tens digit and the ones digit, like our code is kind of doing, it might be tempting for code to say, oh yeah, that 199, that looks like a 99 to me, and give it an A+. So I want to get those cases. I want to get negative values that look like actual grades. So if the code is ignoring the negative sign, I want to make sure that I mark that as bad, as incorrect. Let's give a -100. Actually, I want a couple more here. I want a lot of invalid grades. -1,000,000, +1,000,000. And just for fun, since I ended up doing it last, see, I just made a capitalization error that could have messed everything up. Integer dot, well, not that one because the compiler had my back. Min value. Let's do integer dot min value and integer dot max value. Just for whatever. I mean, it'd be hard to be wrong on those test cases to not mark that as incorrect. But who knows? Somebody might be doing something really strange in their code where they don't handle those boundaries very well, and maybe things just completely blow up. If their algorithm's really inefficient, for example, this might time out. This might run forever. So we want to make sure this code is really robust. So this test suite is a good test suite. I'm feeling good about this one. Which, by the way, how long did that take to write? Not that long. I could have wrote that. I'll stop going down that road. But I could have wrote this in that amount of time. 15 minutes did it take? It doesn't take that long to write a good test suite, at least for a method like this. For the next one, we'll see it's going to take longer, and I actually won't have the time to write the full test suite. But a method like this is quick to come up with a lot of test cases. And then I didn't build my structure yet. And then let's build our structure here for int input in test cases dot key set string actual equals, what are we testing? Compute grades dot compute grade input and then string expected equals test cases dot get insert and with my imports, I actually have to type the whole method name. Oh, that was excruciating. Expected, I like my autocomplete. And then I can import it. And it was helpful last time, so I'm going to add it right away instead of later. I actually am going to use my hint text here because I have a lot of test cases. If we do what we did on Monday, where I used the debugger and just hit resume until we got to the test case we wanted, if we do that, we're going to be here all day. So I want to have some hint text so I know which test case is failing right away, and then I can more quickly go to that one. So my hint text is input, expected, I'm just going to print out all three values, actual. Just going to print out my things. And sometimes I'll leave my documentation right in my test cases. Since this takes up a lot of lines, I'm going to get rid of it just to clean things up a little bit. So here's my test suite. I got a pretty robust test suite, which means if my code passes this test suite, I'm feeling good that that code is correct. Now, it's not 100%. It might actually have bugs in it still. There's a lot of test cases I'm not testing. But the whole purpose of unit testing isn't to make sure 100% that your code is correct. It's to give you a pretty good idea and gain confidence that your method is correct. For 100% correctness, usually something we don't even do in practice, but that's going to be the domain of 250 and 331, CSE 250 and CSE 331, where you're going to write proofs to prove mathematically 100% that your algorithm is correct on every single input, which is a whole different domain. With unit testing, we're gaining confidence that our code is most likely correct. So that's what we want. If my code passes this test suite, I'm feeling good that it's most likely correct. And if your code passes this test suite, I'm confident enough to give you credit for it, that your code is doing what it's supposed to be doing. It'd be tough, like it's definitely possible to have a bug, but it'd be kind of tough to have a bug with all of this, unless you saw the test cases and you intentionally tried to write code that passes this, but is incorrect. Then you could, of course, do it. But it's going to be hard to accidentally write a bug that passes this, but is incorrect. And let's run this. Whoa. Our code we know is incorrect, so we expect this to fail. We went right to, I didn't drip feed it to you this time. Last time we added a few test cases and went one step at a time. This time we went to the whole test suite, and I told you the code's broken. So we expect it to break, and expected on input 90, expected A minus, computed F minus. I'm getting an email about that one, I guarantee it. Some students going to be complaining. If they got 90 in my course and they rightfully earned an A minus, they go and check the hub at the end of the semester and I gave them an F minus, they're rightfully going to be upset, and that's something I got to fix right away. So let's fix this code, because that's an absolutely disastrous mistake, and try to figure out what's going on with this one. So I'll leave the code. I want to resize things a little bit here. And hopefully these ones are, I feel like these ones are fairly easy to spot. I probably should have started with a harder one. And hopefully you proved me right on that this one's easy to spot. But what's the error here? What are we doing wrong? And how are we going to find? If you can't see what's going wrong, what do we do? The debugger. Woo! So with this, this gets a little hard. Well, if you can spot the error, it's whatever. But assuming you can't, or if you can't, I assume most of you can see the error here, I hope at least, is a little tougher. We want to run the debugger, but it's a little tougher to do this because we have like a billion test cases. So it's going to be tougher to get to the test case that we want. And there's a few ways that we can do this. I can add a conditional here. If score, what was our test case we want to know? And unfortunately, the way I'm doing these, that's the wrong one. So unfortunately, the way map.of entries works, we're actually going to get a different test case failing each time, which is a little bit inconvenient for the lecture example. So a D plus on a 69 got an F plus. 83 got a B, or earned a B, but actually got an F. Actually, let's not do it yet. Let's just do the regular debugger. So I'm going to debug this. It looks like all the test cases are wrong. So let's just debug this. Input 73. Go into compute grade. We're going to compute letter and plus minus. Since there's two method calls, we get a choice of which one we want to go into. Yes, this frustrates me every single time. I wish it would just, by default, go into the first one. If I click step into, let's see if it does this time. Okay. So I've had it in cases where it doesn't, though. It just skipped the whole line and said, you don't want to go into either, I guess. And then it just skipped it. So luckily, it didn't do that this time. I think that might have been with Scala, and I think Java does it a better way. So I got into my letter method, but I was too afraid to test it in Java. I just, no, I'll click on it. So we get into our letter method. Our input is 73. Our letter grade is set to the default invalid grade. We're going to compute our tens, which is 7. We're going to check if 10's greater than 9, we'll give an A. Well, that's false, so we skip that. If 10's greater than 8, give a B. That's false, so we skip it. If 10's greater than 7, give a C. This is the one that we're expecting to enter. So we're setting our letter grade to C. That all worked fine. And then we're checking if 10's greater than equal to 6, which is true. Letter grade equals D, and the student's score just went down, grade went down to a D already. And if it's greater than equal to 0, which is true, it's 7, we're going to reassign that to an F and return an F for the student's score, which is bad. It looks like everybody's going to get an F. Jacob says good. Everyone gets an F. So what do we miss? What are we doing wrong here? Yep.
So we should be checking every single conditional.
Yes.
And else keywords.
We need our else's. Yes, exactly. We forgot our else's. Hopefully not many of you are still making this mistake, but the TAs tell me they're still seeing this in office hours, so it was they said it was worth making an example of. We need our else's. When we're doing our conditional checks like this, where each check is assuming that the previous checks were false, we need an else there to make sure that every condition isn't checked. Now with the else, as soon as our if 10's greater than equal to 7, as soon as this is true, this block will be executed, and these checks will be skipped, and we'll go right down to the return statement. That's what we want. We want to make sure we're using our else if and else's and ifs in the right places to get the behavior that we want. Alternatively, we could check if 10's equal, equal. We could do that in this case. But then when we get to the F range, we still have a little bit of jank here. We could check the range. Nothing too complex, but neither is adding your else's. We could check the range if less than 6 and greater than equal to 0, or we could hit it with just a flat-out else on here, and then hope that our check for invalid grades is doing its job. We have a few options there, but if you're setting up your loop like this, where each condition assumes that the previous ones were false, so we're assuming if we get to this check that the value is not greater than or equal to 7, so we know we're not giving an A, B, or C, we can just check if it's greater than or equal to 6 is the same as saying, is it equal to 6? Greater than or equal to 0 is the same as saying, is it between 0 and 5 in this case? We're relying on the previous checks being false if we get to another check. And then we can rerun our code. And fail our code. So we already mentioned this bug. We're given F minuses. We still have to fix this one. And for this, we have a little bit tougher of a situation. This is one I was trying to set up earlier. Let's set it up on this one because it makes more sense. We are failing on the F range And our tests are in non-deterministic order. Well, of course, I get the same one twice in a row there. 58, like all these Fs are failing because we're given pluses and minuses on our Fs. So we want to run the debugger and see what's going on with the plus-minus thing that's getting our F range bad. And I think this one's even more obvious than the previous one. You can let me know if I'm wrong with that assumption. It's hard to judge how much, you all haven't done too much debugging yet, so how much these jump out at you. But I want to set a breakpoint, but I don't want to have to click through all those tests. We have a lot of tests. I don't want to have to click through, like last time we would set the debugger. I would hit the resume button, get rid of my other breakpoint, get in here, and then keep hitting resume until I get a score that's in the F range. And there we go, we got one. And then click through the debugger. But there's always a better way. So we can conditionally break if score. So what I'd like to do is only break under a certain condition. So if score less than 60, and I guess we should do and score greater than equal to 0. So if we're in the F range, I'll just add any line of code, put my breakpoint here, then hit the debugger, and then I'm going to get my first input, which is going to fail. In this, not generally, but I did get lucky. In this case, this is going to give an F plus instead of an F. So we can get right to an instance where we have the condition that we want to check. So that's one way to do it. That's the kind of hacky way to do it. Or you can take advantage of IntelliJ and set a conditional breakpoint right in IntelliJ. So if score less than 60 and score greater than equal to 0, now we have a conditional breakpoint. I'm going to rerun my debugger, and it'll have the same effect as the code that we just wrote, except it doesn't clutter up your code with debugging stuff. So we got an input of 30. We're expecting F, but we're actually expecting F minus because our code's given the wrong thing. And we'll step through this thing and see why. So we're gonna, so we entered into our thing. We have a valid score. We're going to compute the ones, which is 0. Ones is less than 3, so we get the modifier minus. Then we return. And what's the bug? How do we fix this? We're about to return F minus. This is one where I hope y'all just don't want to all shout out at once. Let's just not consider Fs. Let's only enter this conditional check, only enter this check if we're in a range where we expect a letter grade. And since I don't feel like doing it, well, actually, I'll just run it and we'll see it. But we're right here. I'll fix the next one, too. So we move on to the item class. 100 is getting an A instead of an A plus. Not quite what we want. So we want another conditional here. If this is a literal edge case, we're going to add a separate conditional in our code to check that this special case. Then we're going to either just return, we could just return right here, or modifier equals plus. And then like we just saw, the lesson we just talked about, I'm going to make sure I don't forget my else here, or else I could. I mean, in this case, it won't. We're checking if score less than 100, so both conditions can't be true anyway. I'm going to add my else here just in case I update this code sometime in the future and I, for whatever reason, put an equal sign here. I don't want that messing up my code and introducing a bug and giving me one more thing to fix. I don't want that check to even be executed if score is 100. And then we're passing. And at this point, even if you can't see the code, you have this test suite, and the code's passing every single one of these test cases, you should be feeling pretty good that that code is doing what it's supposed to be doing, that it is computing the right grade. Because the ultimate debugger for a method like this is the wrong grade goes to the hub, and holy shit, that's a problem. So we don't want that bug. We're going to test the hell out of our code, make sure we're not having those bugs. But the ultimate debugger is the student in that case. They won't let a bug actually happen unless it benefits them. Nobody's going to say anything about that. But if you get a lower score than you need, The end user is going to be your debugger, and you don't want your end user being the debugger. Once your end user is reporting bugs, you're in a bad spot. Okay, any questions on that example? This is probably worse than simply using else statements. You could also keep the if statement in if you had a return. Yeah, and that's how we saw the code. So last time we saw this code in class, I changed it just so I could introduce the bug, but you could have the return statements right here. One thing with these return statements, if you're getting in the habit of writing conditionals like this, you will also get in the habit of refactoring this. Sometimes there's just a lot of cases where you want to rewrite a method or add a little bit to a method that's not going to gel well with this. You're going to want to process the output a little bit more after the conditional, and you'll have to rewrite it to be the other way. So this absolutely works, and I'm not going to stop you from doing that. By all means, go for it. But just from experience, I've written a lot of conditionals like this, and then rewritten a lot of those conditionals once I want to add another feature to my method. But it works. I mean, this is still going to pass the test. But say I wanted to do the modifier, if I wanted to do the plus minus right here, I wouldn't be able to because I'm out of the method already. Okay, I am going to cut and paste this time because I want to get farther than I did in the last lecture on this one. There's a lot of good stuff to talk about. So I feel like that one, those bugs should have jumped out a bit. These ones, not so much. I want to get rid of the whole thing. Test item. I'm going to run it right away. Last lecture, I was using this button, and I ran the wrong test suite when I was trying to build up to one of my points, and it was embarrassing. So I'm going to run it right away, so this button is going to run the right test. And let's take a look at this item class and see what this thing is even doing. What do we want to test here? So we have an item class that has a description and a price, and any number of sales associated with it. We're going to have a constructor, a getter, setter, typical stuff to start with. I'm going to skip this. We'll explain that in a second. A set price method, so another setter. An add sale method, which is going to take a sale as a percentage and add it to our array list of sales. So, for example, if an item has a price of 100 and we call this method with 10, that's going to add a 10% sale to this item, and then whenever get price is called, it should apply all those sales and then return the sale price of that item. So if I call this with 10 and I have an item worth 100, that should be worth $90 for that item, and we'll assume our units here. And if I add another sale, say I add another 10% sale to that same item, the sales will combine multiplicatively, meaning that $100 item with two 10% sales will be cost $81, not $80. So we're not going to add the sales together, we're going to multiply them together. And we didn't get to it last time, hopefully we'll get there, but compute tax is going to take a tax rate, and I forget why I use tax rate and sale percentage, why I mix these like this, but tax rate is a decimal, so we're going to multiply the price by the tax rate to get the tax. And then another method, which is going to return a line that should be printed on a receipt, which is going to be the description of the item and its price, including the tax. And I also have a method round by two decimal places. I forgot what method does this for me, so I just rolled my own because I didn't feel like making a Google search. But I'm going to multiply input by 100, round it, and then divide by 100, which will effectively round to 2 decimal places. Okay, so that's what the class should do. Let's get a test. Of course, we know that there's at least one bug in here. So let's write a test. For this, this class doesn't lend itself well to a map of input-output. There's no clear input-output behavior. We're modifying the state of the item and then asking for its price. So we're going to do this. We're going to do this another way. Item equals new item, and I have an important question. What are we going to sell? 1 soul. What's the price of a soul? 2 semesters at UB. I don't know if we can do sales on this one, though. Just for the sake of argument, let's say, now I regret saying that we're going to assume our units are dollars. Let's assume our units are something else, and I'll leave it vague. But our 1 soul is going to be worth 1 million somethings. And then we can right away start asserting things just to make sure our getters and setters are working the way we want. So let's do, I lost track of how many times I pressed the button. Let's make sure that item.getPrice with no sales applied is going to be 1 million. I'm going to check to make sure it's accurate within 0.001 units of commerce. And assert equals soul. Man, it bugs me this thing pops up. I changed my settings so it didn't pop up for one lecture, but then I wanted that for regular coding. So I turned it back on. And then get description, make sure the description is a soul. And then we can start messing around with this item.addSale. And I'm going to go right to it. We don't have a ton of time, so I'm going to go right to multiple sales. I would write a test case with 1 sale. I would call the setPrice method. So this is where I am going to shortcut. On the previous example, we did get a full test suite, so we got at least one example during a lecture. It's hard to do those just in a 50-minute time slot. So item.addSale, item.addSale. Oh, what am I doing here? I want this to be 10. My sales are percentages. My tax is a rate. Let's do a 10%, and let's say half off, too. We're going to have a fire sale on souls today. And then my item dot, just grab this whole thing. I'm going to use a variable here, so this is easier to read, because this is where things can go wrong to the point where we have to debug. We're going to weigh free souls today. Expected, and now I have to do some math. 450,000, right? So if I got the right number of zeros here, that's 1 million. 10% off would be 900,000, and then half of that would be 450,000. So we expect the price after this sale to be 450,000. And our code's broken, so let's watch our test fail. I'm going to make sure I'm running the right test again. Test item, and it passed. But I have a solid test suite, right? I should be able to submit to this in Autolab and expect credit, right? Come on, I got a compound sale here. Christ. So what's my bug? What's my bug, and what am I doing wrong in my testing? If I know this code's wrong, and this is a case where if I see this in office hours, this is what I do. I say, you know what, just to humor me, and take this line and paste it. So you're checking the price twice. If you ask an item for its price twice, the price shouldn't change. Nothing should happen here. You ask it twice. Both, if the first one passes, the second one should pass. It's the same exact test, right? And I say, okay, can you run that test? And then you'll see this, and I'll say something like, there's your bug, and then I'll probably just walk away. Because at that point, you know what your bug is. I've exposed the bug, and then it's up to you to actually debug it, if that's an office hour visit. But this failed. Why did this fail? Tremendously, too. So if we can't just spot it, you could stare at the code and just try to brute force your brain to see the solution. If you can't, I assume most of you can't. Maybe on this one, I don't know. At this point in the semester, maybe you can. This one's a bit trickier. The previous example, I hope most of you could spot those bugs. This one, a little bit tougher. But we're going to run our debugger. We only have one test case, so we don't have to go to a specific spot. We're going to go into the getPrice method. The price is going to iterate over all the sales and compute the sale price. Now, we know this method works. We know that it returned the right price. So let's see what it's actually doing wrong. So we have the price of the item. It's $1 million. We're about to add a 10% sale. It went to 900,000. Oh, I said dollars. Damn, I was trying not to. And then we have our 50% sale. We go down to 450,000 units. We're done with sales. Our item has the 2 sales in it that we expect. We're going to round that to 2 decimal places and return our 450,000 units. As we expected. That test is going to pass because we return the right value. We get into the next call, and the price is $450,000. We're going to apply a 10% sale to it. We're going to go to the next sale, apply a 50% sale to it, and return 202,500 units. So what happened here? What did we do wrong? Yep.
The price is actually being stored in the object itself. It has to be stored as a separate variable.
And this, yes, exactly. And this is a very common issue that we see. So what we would want is double price equals this dot price and compute the price each time this method is called. We don't want to modify the state of the object. Once we modify the state of the object, we're actually following the reference, going to the heap, and changing the state of the object, which means this method has side effects. But getting the price, a getter method, it shouldn't have any side effects. It shouldn't change anything with your object. So we don't want it to change anything. We don't want it to actually change this price. We just want to compute this price with the sales applied and return that. And now we're passing our test because we're not changing the state. This is a much more common error. I see this all the time. I've seen it up to and including task 9. I saw